Hello, Secondary Math 1 students. Let's go over this Chapter 8 review for our test coming up on Basics of Geometry. So here's question number 1. Match each question with the appropriate answer. How do we label a point? Points, as we know, are always labeled with a capital letter. And as you do your drop-down box, you will look for a capital letter as your answer. Anytime we're going to label a point, we use capital letters, not lowercase, but capital. Number 2, how do we label a line? A line can be labeled a couple ways. We can use a lowercase letter, or we can use 2 capital letters that are both on the line. Now, when you do your drop down, be careful because a lowercase letter is going to be one of your options. But let's choose the best answer. Let's choose the one that says a lowercase or 2 capital letters, okay? How do we label a plane? A plane is a surface. We're going to use the fancy script capital letter, okay? Or we can use 3 points, which would be 3 capital letters that are on the plane, okay? So either of those options is how we'll label a plane. Okay, so question number 2, it says name a point on the plane. Now on the plane we have 4 points. J and K are not on the plane, neither is I. Okay, so it could be any of those 4 in truth. We're gonna pick letter H because there's only a couple to choose from. Letter G is also one of your options, but I think that one's gonna fit better down here when we say what's the intersection of IJ and DF. Remember, 2 capital letters is a line, so this is IJ is this line, and DF is this line. Where do they intersect? At G, so we'll use G down here, so H would be an appropriate one for here. Name a line. You really have 2 choices when you do your drop-down menu. You only have 2 choices. You have DF and you have JK. Now, DF absolutely is a line. JK, there's really not a line drawn in there and it's off the plane anyway. Let's just go with DF. Remember, it's a line is any 2 points. We could have named it a couple different things, but DF's what we've got for a choice. Name a plane, 3 capital letters. You have a couple choices as you look at your drop-down menu, HDF or DGF. I'm not going to use DGF because those are collinear. They're all on the same line. That's not necessarily going to identify a plane, okay? We want to use 3 that are not collinear, so I think we need to use HDF there. Name 2 points that are collinear. Now be careful here, points are capital letters, but I'm not going to list them like this because that represents a line. We're just going to say 2 points that are collinear. How about D and G? And we're going to say it as D and G. We're listing 2 specific individual points, but they are collinear because they're on the same line. That's what collinear means. Number 3 says, what is the length of AC if AB is 12? So looking at the picture, what's the length from one end all the way to the other if AB is 12? They're giving us this value here is 12. What's the full length? Well, I know that B is the center between that because of these 2 marks. They're telling me that those are the same length. So this one has to be 12 as well. So if we want AC, it's just 12 plus 12, which is going to be 24. Number 4 is kind of the same idea, only they didn't give us some straight up numbers, which is going to make it a little more difficult. AB, it says, is 2x plus 4. That's the length. Doesn't mean a whole lot right now because we don't know what x is. BC, that length is x plus 6, and it wants to know again the full length, okay? In order for us to figure that out, we're going to need to know what x is. So to be able to figure out x, we need an equation. I hope you guys can see that this equation would be what's true about our figure. Hopefully you'll agree that 2x plus 4 is the same length as x plus 6, so we're going to set them equal to each other. That gives me an equation that I can solve. I can subtract x to get x plus 4 equals 6, and then I can subtract 4, which gets me x is 2. Now if x is 2, I can come back up here and say, well, if x is 2, 2 plus 6 is 8. Right here, 2 times 2 is 4, plus 4 is 8. And they should be the same length because that's the midpoint. What's the length of AC, the full length? 8 plus 8, which is 16 total. Number 5, endpoints of CD are located at those places. Find the coordinates of the midpoint. When we're talking two endpoints, now on a graph, 3, 5, 3, negative 5 is down here. 7, 9 is 3, 4, 5, 6, 7, and it's going to be clear up here somewhere at 9. And we want to know the coordinates of the midpoint, the middle between those two. The quickest way to do this that we learned in the assignment is, let's just take the average of the y's and the average of the x's. So what I mean is, the x's are 7 and 3. 7 plus 3 is 10. And then we divide it by 2 because there's 2 of them. So my x value is 5. Then we do the same with the y's. 9 plus a negative 5 is going to be 4. And then we divide it by 2, which is 2. So we get 5 and 2 is our coordinates for the midpoint. Okay, number 6. One end is here, and then the midpoint is here. Now this one's a little bit different. This one's saying we're going to go to 5, 1, 2, 3, 4, 5, and then to negative 6. Okay, there's our first point. The midpoint is at 1, 2, 3, 4, and up 3. This is the midpoint. Here's an end point, here's a midpoint. Somewhere up this line, up in this area, is going to be the other end point, and we want to know those coordinates. So that's a little bit different than the previous question. To me, the easiest way to do this is to say, well, how did I get from the end to the middle? Let's count a rise and a run. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going up 9 and left 1. If I go up 9 and left 1, let's do that again from M. Let's go up 9 and left 1. Now M is at 4, 3, so if you can picture, if I go up 9 from 3, where am I going to be? At 12. And if I go left 1 from 4, I'm going to be at 3. In other words, this point is going to be at 3, 12. And that's the other end. Now number 7. Find the distance between these 2 points. The quickest, best way to do this that I tried to portray in our assignments is, let's make a right triangle out of this. This becomes a Pythagorean theorem problem. The length of this side, 1, 2, 3, 4, and the length of this side, 1, 2, 3, 4, 5, 6. We can use the Pythagorean theorem. 4 squared plus 6 squared equals c squared. And that is our c, that's our hypotenuse. 16 plus 36, squaring those, I add them together and I get 52. I need some number squared is 52. Or in other words, I need the square root of 52. You punch that in your calculator, you'll get roughly 7.2. And that's our distance using the Pythagorean theorem. Number 8. This one right here, find the distance between these 2 points. Well, this is just like the last problem, except we don't have the picture. Now, to refer back to that last problem, here's what's interesting. We drew the right triangle, but what I want you to notice, this height of 6, look at our 2 y values. 8 subtract 2 is that 6. Look at the x values. 7 subtract 3 is that 4. So rather than draw the picture again, what if we just subtract y's and x's and come up with those 2 pieces? So for this problem, let's just take our 4 minus 0, which is 4, and let's do 1 subtract a negative 8, which is 1 plus 8, which is 9, and those become our 2 side lengths. So we can do 4 squared plus 9 squared equals c squared. These would be the sides of a right triangle if we were to graph this and draw the triangle. 4 squared is 16, 9 squared is 81, 16 plus 81 is 97. I need the square root of 97. If you punch that in your calculator, you'll get approximately 9.8. And there's the answer that we want. Number 9, find the perimeter. The perimeter is the distance around the triangle. Okay, well, we already know 2 of these by counting. 1, 2, 3, 4, 5. That's a distance of 5. 1, 2, 3, 4, 5, 6. That's a distance of 6. We need the third distance so that we can add them all together. We can't just count diagonals. That's why we have to use the Pythagorean theorem. So we're going to find this third side that I'll call C. We'll do 5 squared plus 6 squared equals c squared. 5 squared is 25. 6 squared is 36. 25 plus 36 is 61. and the square root of 61. And if you punch that in your calculator, you'll get about roughly 7.8. So our missing side is 7.8. Again, we're asked to find the perimeter. That means all three sides added together. So we've got to do 5 plus 6 plus 7.8. I got to add all three of those together. And when you add all three of those together, you'll get 18.8. Number 10, find the area. This is actually a little easier than the previous problem because area of a triangle is just half base times height. Well, the base we just counted a second ago, 1, 2, 3, 4, 5. The height we counted just a second ago, and it was 6. We just have to do 5 times 6 and take half of that. Half of 30, which is 15. Number 11. Is the following triangle a right triangle? Well, if it's going to be a right triangle, this angle L here needs to be a 90-degree angle. Now, being 90 tells me these two lines here are perpendicular. We know something about perpendicular slopes. They have to be opposite reciprocal. If I check the slope of LM here, I'm going to rise 1, 2, 3, and I'm going to run 1, 2, 3, 4, 5. This slope is 3/5. Actually, it's a negative 3/5 because it's falling to the right. Or I can count up and left, gives me the negative value. What's the slope of LK? If I go from L to K, I'm going to rise 1, 2, 3, 4, and I'm going to run 1, 2, 3. That's a rise of 4 and a run of 3. Opposite reciprocals? I don't think so. They're opposite, negative and positive, but reciprocal means you flip it. 3/5 flipped would be 5/3. If this were 5/3, these would be perpendicular and it would be a right triangle. But since it's not, we're going to go with this answer right here. No, the slopes are negative 3/5 and 4/3, which are not opposite reciprocals. Okay, number 12. On this one, it's asking for the length of BC. BC is from here to here. That's straight across. We can count it. 1, 2, 3, 4, 5. That would be the same here. 1, 2, 3, 4, 5. Okay, so that's going to answer AD and BC. These are both 5. What about the length of AB? Now, AB's diagonal. Can't just count it. We've got to use our Pythagorean theorem here. Okay. So I'm going to create a right triangle, 1, 2, 3, 4, and 1, 2, 3. And I'm going to be able to find side C there using this as my hypotenuse. So 4 squared and 3 squared equals C squared. 16 and 9. 3 squared is 9. And that's 25. So I need the square root of 25, which is 5. How interesting. That's 5 as well. And so would that one be? All of these are sides of 5, okay? Now, classify the shape. Well, if all 4 sides are equal, what do we call this thing? Well, typically we would think of a square, but the problem here is it's kind of slanted and they're not 90-degree angles. But I know that a square that's kind of slanted turns into the shape that we call a rhombus. A rhombus has all 4 sides equal, but the angles aren't 90s. Are all the angle measures the same? I think we got obtuse here, and we've got acute there. I would say I don't think so. Those are not. 13, what's the area? Now, we already know these are all side lengths of 5. We figured those out. The area is base times height. Be careful here. This slanted side is not our height. The height is from the top straight down to the bottom. 1, 2, 3, 4. The height is actually 4. Our base is still 5. We want 4 times 5 here, which is 20. Number 14, what's the perimeter? Well, we already figured out that all 4 sides are 5. If I add all 4 sides together, because that's what perimeter is the distance around it, 5 plus 5 plus 5 plus 5, that's going to be 20 as well. Okay, and that's the perimeter. Okay, that's the review. Hopefully that helps you, and good luck on the test. Take care.